नमस्कार दोस्तों, मेरा नाम सुरेंद्र कुमार है और मैं अजय कुमार इंजीनियरिंग कॉलेज में कंप्यूटर साइंस डिपार्टमेंट में असिस्टेंट प्रोफेसर पर हूँ। मैं आज आपके सामने लेके आया हूँ डिस्क्रीट मैथमेटिक्स का एक बहुत ही अच्छा टॉपिक जिसका नाम है रिलेशंस। रिलेशंस को हम पढ़ने वाले हैं सेट थ्योरी के अंदर, जो कि यूनिट 1 में है बीटेक थर्ड सेमेस्टर के लिए। रिलेशन के अंदर हम रिलेशन में हम डिफरेंट काइंड्स ऑफ रिलेशन क्या होते हैं उनको हम कैसे पहचानेंगे विद द हेल्प ऑफ सम एग्जांपल्स। So now let's start. So introduction of relation. So उससे पहले हम जान लेते हैं कि सेट होता क्या है। तो a set is defined as a collection of distinct objects. So in a set we have distinct objects of the same type. There must be defined a type that must be same or a same class object. What is the purpose of study the sets? So the purpose of a set are called elements or members of the set. We collect the same kinds of elements or members in a set. So a number, alphabet or names, etc. are the examples of set. We can have more example from real life scenario like set of all rivers in India, or we can say set of all vowels in alphabets. So we broadly denote a set by the capital letter A, B, C, and the elements of the sets are denoted by the small letters like A, B, X, Y, Z. So if a set A and A is one of the element of A, then we can denote it as A belongs to A. A belongs to set A. That means it's element of A. It's an element of set A. So before starting the relation, we must understand what is the ordered set. So ordered set, it is defined as the ordered collection of distinct objects. For example, we have roll number of a student. So it is in a order. It is in increasing order or decreasing order. It has some order. Or we can say a set weekdays which contains weekdays: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday, right? So in this way we can say this is an ordered set which have a sequence, which maintains a sequence or maintain a order. Now we come to the ordered pair. What do you mean by ordered pair? So as we have an ordered set, so an ordered pair consists of two elements. If we are talking about the ordered pair, that means it consists of two elements. What are the two elements? Such that one of them is designated as the first member and other is second member. So here you can see if first is n-1, the next is nth element. So we can have the example of ordered set with the help of binary relation. So now what is binary relation? So whenever sets are being discussed, the relationship between the elements of the set is the next thing that comes up. So relations may exist between objects of the same set or between objects of two or more different sets. So if for example if we have a set A, so we can define a relation on the same set A to A, or if we have two sets A or B, then we can define a relation like A relation B. So here we have taken example. So how let P and Q be two non-empty sets. A binary relation R is defined to be a subset of P cross Q, Cartesian product of P and Q from a set P to Q. If A comma B belongs to R, that relation is created on Cartesian product, a subset of that Cartesian product, and there is a ordered pair A comma B that belongs to R, and R is a subset of P cross Q. then A is related to B by R, or you can say ARB. You can represent it as a ARB. If set P and Q are equal, then we say R is a subset of P cross P, or P is relation on P. Let's take one more example. We have two set A which contains A, B, C elements, and we have another set B which contains R, S, T, three elements. So if a relation R is defined on set A to B, then A comma R, B comma R, B comma T, C comma S is a relation from A to B. As you are seeing, there are not all the ordered pair, because we have created a particular relation, right, on particular relation between the ordered pair or the ordered set. So R is one kind of relation. There may be other relation also can be created. Second example, we have a set A and B is equal to A, that means A to A, you can say. So it is a relation 1 comma 1, 2 comma 2, 3 comma 2, again is a relation, or this kind of relation is called equal relation. I hope you understand what is relation and what are ordered pair and how ordered pair have their role in relations. Another example is, if a set has an element, so how many relations are there from A to A? So there are some, you have a relations from A to A because you have A cross A, yani N cross N. If we have A set which contains an element, again B set contains an element, the relation Cartesian product A cross B will contain N cross N elements, right? That is N square. And if we talk about how many relation can be there, so it is 2 raised to the power N square. So these number of relations can be formed from A to A, right? So now we discuss it is broadly how you can determine the ordered pair of a relation. For example, if you have a set A which contains two elements 1 and 2, determine all relations from A to A. So we have to determine all relations from A to A. So first of all, we want to know how many relations can be generated with the help of this set A. As you see, 2 cross 2 will be element in A cross A Cartesian product, that are 4. Or if you talk about the number of relations, so that is 2 raised to the power 4 will be 16 relations can be created with the help of a set A which have only 2 elements. Let's start one by one. What are different kinds of relation can be created with the help of set A to A? A relation can have single element or no element. So that's why we have these 4 relations containing single elements, and this set R16 is no element, that is empty set or phi set. So this is also a relation. Rest we can have a relation 1 1, 1 2, 1 1 and 1 2, then 2 2 and 2 1. So these 4 relations can be created with the help of given set for single order pair. If we imagine a relation, some relation having 2 ordered pair, so we can create with the help of these ordered pair 1 1, 1 2, 1 1 2 1, 1 1 2 2. तो 3 इससे बन जाएंगे आपके. Again we talk this one, so we will create relation 1 to 2 1 or 1 to 2 2. 1 to 2 1, 1 to 2 2. Then come with 2 1, 2 1 2 2, right? So these are the 6 relations which can be created with the help of 2 to order pair. Now we come to the 3 3 ordered pair. So 1 1 1 2 1 1 1 2 and add one more added pair 2 1. In this way you can create these 4 relations also, distinct relations, and last it will contain all the ordered pair, all the 4 ordered pair, right? So in this way you can create total number of 16 relations with the help of a set containing only 2 elements. I hope you understand this very well, or you can pause the video and you can recheck the relations, how the relations are created with the help of a set A having 2 elements. Now we discuss some technical terms of relations, domain and range of a relation. If we talk about domain of a relation, that means is the set of elements in P which are related to some element in Q. As earlier you have seen, you have 2 sets P and Q, and you have created some ordered pair on P1 and Q1, right? So this ordered pair, it is a set of all first entries of the ordered pair. So first entries, that is related to P. So set of all entries of the ordered pair is called as a domain. Or if you talk represented with the help of, it is represented with the help of dom R. If we talk about range of relation, so the set of all the second entry of the ordered pair is called domain, sorry, range of the relation, and it is written as a AN of R. We can see it with the help of easy example. We have 2 set A and B, and the given relation is this one. If we try to find out the domain of the given relation, then we will see the first element. It is again 1, it is again 1. So these are 1, 2, 2, 2. So we have only 2 elements in domain, 1 and 2. So here you have written domain of R is 1 and 2. If we talk about the range of R, so we will see the second element A, B, C, again B. So we will not take it, again C, will not take it, it's D. So we will have these 4 elements in range A, B, C, D. So here you can check, it is A, B, C, D. So it is very easy to find out the domain and range of the given relation. Okay, fine. So one more thing we have to discuss here, what is the complement of a relation. So complement of relation is, consider the relation R from a set A to B. The complement of relation R denoted by R inverse. It is denoted by R inverse. So R inverse is AB such that AB doesn't belong to R. Those ordered pair which doesn't belong to R. So for example, if we have a set A x y, and here you have given a relation R, and you want to find out the complement of this relation, then first of all you have to find out the x cross y. Cartesian product of the given set, and then filter out those ordered pair which are already in R. So 1 8 is already in R, 2 8 is already in R, 1 9 is in R, and 3 9. Rest of the ordered pair will be considered as a R inverse or R's complement of R complement of the given relation. Now we will discuss the modern day application of relations. We can use this relation topic or relation concept in different kinds of subjects to study, or in the real life scenario like relational database, where data is stored in the form of SQL query, right? Or you can go with the graph theory also, where you can represent your edges or your graph with the help of relations, right? So A connected with B, B connected to C, C connected to D. That can be used for transportation of networks or linked list of friends of Facebook. These kinds of applications can be used. Yeah, these kinds of applications are using the relations topic. Or you have artificial intelligence and machine learning. You can use decision tree with the help of relation. You can use classification problem with the help of relation. Or in formal automata theory, you have regular expressions, and compiler and interpreter basically rely on the relation to describe the transit between states. So here a number of cryptography, web search algorithms, ontography, operation research, optimization technique, recommendation system, computational biology, and bioinformatics. So you have a number of real life applications of relations, like in social media, in behavioral analysis of persons. So here we will discuss a example. So let A is a set 2 4 6 and B is a set 1 4 5 6. Find out the relation from A to B defined by is less than or equal to. Is less than or equal to relation find out करना है, उसके लिए आपको R बनाना है. तो first of all we have created all the ordered or Cartesian product of A cross B. Now we will check one by one which are satisfying, which order pair is satisfying the given relation equal to. You will check 2 1. 2 1 is less than or equal to relationship? No, because 2 is greater than 1. Following the relation, it is not in our relation. We talk about 2 4 years, 2 is less than 4, so it is in our relation. 2 5 is in relation, 2 6 relation, 4 1 it is not in our relation because it is greater than 1. 4 is 5 because it is equal to also. 4 5 is okay, 4 6 is okay, 6 1 it will not satisfy the relation, 6 4 will satisfy the relation, 6 5 not, and 6 is okay. So in this way you can create a relation having these elements which are satisfying the given condition. You can find out easily domain and range of the given relation by taking out the first entry and second entry of the given ordered pair. So here you can find out the domain of the given relation is 2 4 6 and the range is 4 5 6. I hope you understand this concept. Now this is inverse of relation. So inverse of relation is just like that. If you say R inverse, it is A B relation will be given as B A form, right? So here you can see with the example of this, if you have 1 2, you will just write for inverse of relation 2 1, 3 1 3 will give 3 1, 1 1 will be same, 2 2 will be same, 2 3 will written as 3 2, and 3 3 will be same. So this is your inverse of the relation. I have previously given R inverse for complement. You can change the notation with the help of C also, RC. This is complement because both the two relations will be same. So it is RC, R complement, right? So now we come to the representation of relation, how you can represent your relation in matrix format. Like if you have some kind of relation exist, then you will give 1. If it doesn't exist, you will give 0. So here the relation is giving, you will write in the form of matrix 1 2 3 A B C D. So 1 A is present there, 1 A is present there, so it is okay. 1 B is okay, 1 C is okay, 1 D is not there, so that's why you have given here 0. Same, you have 2B, 2B, this is 1, 2C and 2D. Rest are not present in your relation R, so you will give the 0 all the entries, right? So in this way you can represent your relation with the help of matrix representation. Or with the help of directed graph, you have directed graph, then you will write these 4 element 1 2 3 4 given set element, and you will display the relation between the element as you have 1 2 display. So 1 2 2 2, that means 2 के ऊपर 2 आपने सेल्फ होगा, 2 4, 2 से 4 की तरफ जाओगे आप, 3 2, 3 से आप 2 की तरफ जाओगे, एंड 3 4, 3 से आप 4 की तरफ जाओगे, 4 1 है, 4 से आप 1 की तरफ जा रहे हो. नाउ यू हैव 4 3, सो 4 3 यानी 4 से आप 3 की तरफ. इन दिस वे यू कैन शो विद द हेल्प ऑफ डायरेक्टेड ग्राफ द गिवन रिलेशन in pictorial format. This relation is an arrow diagram. You will have 2 sets A and B, P and Q, and you will showing 1A. 1 is related to A, 2 related to A, 3 related to A. So these 3 ordered pair, 1 to B, 1 to B, 4 to B, 4 to B, and 4 to C, 4 to C, and 4 to D, 4 to D. In this way, you can represent relation as an arrow diagram, right? Relation as a table. In the same way, you will create a table and put a cross mark where you have the relation pair present. Otherwise, leave blank rest of the table entries. This is relation table. So here are the types of relations. What are different types of relation with this relation subject? We will discuss it in our coming videos. Thank you so much.